In our first unit on quadratic functions, we learned that when you graph a quadratic function, you get a shape called a parabola, and this shape has a few features that we've been talking about. So on this page, we're going to put all of our definitions for features and all of our formulas together, and you'll notice that my copy is color-coded and yours is not. So one thing that you can do to get yours color-coded is to just use a highlighter to kind of box the same way as I do with whatever your favorite colors are. So we have a picture of the parabola. Let's start by graphing what the equation would be. And I will give you the equation for this parabola here. It is y is equal to x squared minus 2x minus 8. And I want you to remind me why this equation is a quadratic equation. The part of this equation that makes this quadratic is the fact that the largest exponent of x is 2. We have an x to the power of 2. Same question about the graph. How can you tell that this graph is a quadratic graph? One reason is because we get the shape called a parabola, and a parabola is the type of graph we get with a quadratic function. Now put your pencil down for this part because I want to show you a pattern, but I don't want you writing it on your paper because I don't want you ruining these notes. But this is a cool pattern that some of you might find helpful. Now if I start at the vertex, I can do kind of like a slope thing to get my next point. So what I notice here is that I can go right 1, up 1 in order to get to this point right here. So we had right 1, up 1. Keep that in mind. Now, last year when you learned about lines, you would just keep going, okay, right 1, up 1, right 1, up 1, right 1, up 1, and that's how you get this straight line. And that doesn't happen with parabola because the slope keeps changing. So let me change color for the second slope. Okay, so one more time, my first slope is right 1, up 1. Let me see what my second slope is going to be. So if I go to the right 2, 1, 2, am I going to go up 2? No, I'm going to go up 1, 2, 3, 4. Okay, so my second slope required that I went up 4 for every time that I went over 2. Let's change a different color. How about green? Let's see what the third slope is going to be. So if I go to the right 3, 1, 2, 3, let's see how far we have to go up to get to the next point. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now I'm just curious to see if I were to go right 4. Okay, let's do this in orange. If I were to go right 4, no penalty for this one, I just want you to guess. How far up do you think that I would have to go in order to get to the next point? Well, it turns out the correct answer would be 16. You might have noticed this pattern that for whatever you go to the right, how much you go up is the square of that. So for example, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. So I'm going to erase this. This is not something that you need to know for your test, but it's an interesting pattern that can help you to recognize some parts of the equation later on. Let's go in order, starting with box 1, which is below, and it says the direction. So the direction is where the parabola opens towards, and it's usually the direction that the arrows are facing. Remember, the arrows don't tell you where it's going. The arrows just tell you, hey, there's more up here on this graph that we didn't have room for. So we have A, B, and C from every quadratic equation. Go ahead and remind me what would be the A value, B value, and C value for this quadratic equation. A would be 1, B would be -2, and C would be -8. So in the case that A is positive, the parabola is going to curve up, and that's going to have a lowest point, which is called a minimum. Where A is negative, the parabola is going to curve down, and we're going to have a maximum. So curving up looks something like this, and curving down looks something like this. I don't think that there's a corresponding spot for this yellow box on the graph, but in this case, the particular graph is facing up. How can you tell me from the equation that you knew the parabola would face up? The parabola is facing up because A is +1. Now let's go over to the red box, box number 2, which is about the axis of symmetry. Axis of symmetry definition is a vertical line that acts as a mirror for a parabola. Personal choice, if you want, you can leave this off, but I'm just going to remind myself that the word axis is a fancy word for a line. Symmetry, I like to just think about the word mirror. That's a good word for me when I think about symmetry. And since every parabola is facing up or down, we always want an axis of symmetry that is vertical. So let's go ahead and remind ourselves that if you want a vertical line on a graph, the equation should always look like x equals some number. You might be thinking it's supposed to be y equals because the y-axis goes in the same direction, but it's kind of the opposite. If you were to do y equals some number, like, I don't know, y equals 3, you would actually get a horizontal. So if you have a highlighter, we have both of these written, but we should highlight this one because we only want a vertical axis of symmetry for parabolas. To find the axis of symmetry, and remember, this is the instructions for the equation, not the instructions from a graph. So these are the instructions as if you were unable to see the graph. We use the formula x is equal to negative b over 2a. And I remember from our equation that a is equal to 1, b is equal to negative 2, and c is equal to negative 8. So I'm going to substitute these in. X is equal to negative blank over 2 times blank. Really quickly, I know sometimes you saw the negative in front, and I do want to remind you, you can put the negative in front. I think I kind of warned you. My favorite way is to think of the negative like it's in the numerator. That's the way I see it. So if you don't like that, feel free to put the negative out here in the front instead. That's completely fine. Or you could even put it in front of the 2 instead. So what number should I place here in the orange? In the orange spot, we should put the b value, which is negative 2. And what number should I put down here in this orange? That should be the a value, so we should put positive 1. Now, for the purpose of taking good notes, you want to highlight. These notes are going to be used for a couple of months, so I want you to think if you're going to remember this in a couple of months. No, you're not. So let's go ahead and highlight. I'm going to do b in pink. There's my negative 2. That's why that goes there. Be careful to not highlight this negative that's in front of the negative 2 so that when you're looking at your notes, you can go, okay, one of the negatives is from B and one of the negatives is from the formula. Then I'm going to switch to green and I'm going to highlight 1 for the A value. Okay, and now go ahead and pick up your calculator and use your favorite method to simplify this. I'm going to simplify this in my head. Negative 2 is positive 2. And then 2 times 1 is 2. 2 divided by 2 is 1. So my axis of symmetry is not 1. My axis of symmetry is x equals 1. The reason I have to say x equals 1 is because 1 is a value. X equals 1 is the formula for a line. Now let's look at our graph and see if our answer makes sense. Now, if you want, you can copy the color coding here, pick whatever color you like, and box number 2. So then it matches with my red box over here that's pointing to the axis of symmetry, which looks like, yes, it is at x is equal to 1. And you can see that because it passes through the x-axis at the value of 1. Up next, box number 3 is to find the vertex. And this is on purpose that we found the axis of symmetry before the vertex, because in order to find the vertex, which is a point x comma y, you need to find the axis of symmetry. We find the x coordinate from the axis of symmetry. Maybe you want to also include in these notes, just to bring it home, this is the formula that we use to find the x coordinate for the vertex. Now, to find the y coordinate, you're going to substitute your value from the axis of symmetry into the quadratic equation. Pause that so that you can substitute the x value from axis of symmetry into your quadratic equation. Personal choice, if you don't want to write AOS, which is short for axis of symmetry, you can write out axis of symmetry. You know yourself, and if you're not going to remember what that means, just write axis of symmetry. So below this, let's put our equation, which is y is equal to x squared minus 2x minus 8. And below that, let's set this up for substitution. Y is equal to blank squared minus 2 blank. minus 8. And can you tell me what should go in those blank spots? What should go in those blank spots is our answer from the axis of symmetry, which was x is equal to 1. So I'm going to choose a third color here. Let's see, I did pink, I did green. Let's do yellow. I'm going to highlight this x equals 1 in yellow, and I'm going to use that same color here and put a 1 there. And maybe we should put x equals 1 over here. And then I'm going to, now this part, if you don't like it, because it's too messy, you can feel free to skip this. But what I want to do is kind of draw an arrow, really reminding myself, okay, I took this, and that's how I got that over there. It's your choice whether you want to use your calculator or do this in your head. I recommend you do both. That way, if you make a typo, you can check it. And that way, if you make a mistake while calculating in your head, you can check with your calculator. So we have 1 squared, that's 1 times 1, so that's 1. We have negative 2 times 1, so that's going to be negative 2, and then minus 8. So this is subtraction. We're not doing negative 2 anymore, it's minus 2. I want to combine negative 2 and negative 8 first, and we get negative 10, and then bring down the 1. 1 minus 10 is negative 9. So I believe this to be negative 9, but I'm also going to double check my work on a calculator by typing in 1 squared minus 2 times 1 minus 8, making sure I don't forget any of the parentheses that I've written. If you're using your calculator, remember at this point, this is minus 2, not negative 2. So that's the button that's to the right, that's not in parentheses. And I'm also getting negative 9 here, so I'm happy with that. So I haven't written my answer yet though. I have x and I have y. I have not reported the vertex until I put this together and I say that my answer is positive 1 comma negative 9. This is my vertex. Now let's check the graph that's already on this page to see if 1 comma negative 9 makes sense. Okay, if we go right 1, down 9, yes, that does look like it's the vertex. Now I'm going to write the word vertex here, as well as putting 1 comma negative 9. And I think that we should also, over here where it says x equals 1, I'm going to put AOS. Again, if you don't like that, you can write out axis of symmetry where you have space. The y-intercept is where the parabola crosses the y-axis. To find the y-intercept, you don't need to do more other than identify the c value. The y-intercept is found from the c value, which is negative 8, so our answer here should be 0 comma negative 8. Taking a look at the graph, I can see 0 comma negative 8 is on there, so we can put y-intercept. You can put that if you run out of space. I think I can fit it, and then let's put 0 comma negative 8. Last one, x-intercept, is usually the most difficult thing to calculate. So we save that one for last. And we already kind of, spoiler alert, can see on the graph where our 2 answers should be. It says it's where the parabola crosses the x-axis. We're not going to do option 1 yet because we don't know how to do that. So you can go ahead and cross off option 1. We'll get to that in the next chapter. Right now, the only way we know is 1 from graphing or 2 from quadratic formula. Some other names for the x-intercepts are roots, zeros, or solutions. Let's use this space above to write out the actual quadratic formula, x equals, and now I'm going to rewrite the quadratic formula, and instead of using the variables in here, I'm going to take those out and replace them with blanks. Now we've already identified A, B, and C, so let's substitute these in carefully, and I need you to color code. Remember, these are your notes for later on. Let's color code to take good notes. Copy my color coding pattern here, and then substitute A, B, and C into the formula where they need to go. And now I'm going to use my calculator to type in this formula 2 times, 1 with addition and 1 with subtraction. In my first round, I got 4. Now I'm going to copy and paste, and I'm only going to change the plus sign to a minus sign. So my two answers look like they're +4 and -2.